Now it's time to talk about how to determine the equation of a line passing through 2 points. In the figure before you, you see a line that is passing through the ordered pairs 0, 2 and 3, 0. Now, one thing we can note is that we have a vertical change called delta y, which is the rise, if you will, and a horizontal change here, delta x, which is the run, which is how we move from one point to the other. So if I were moving from 0, 2 to 3, 0, I would go down 2 units and right 3 units. If I'm moving from 3, 0 to 0, 2, I go left 3 units and up 2 units to achieve the same thing. We call the measure of rise divided by run the value slope, or as I prefer to say, change in the y-coordinates versus change in the x-coordinates. When we do this calculation, either direction, y-coordinate minus y-coordinate, corresponding x minus corresponding x-coordinate, we see that we get a value of 2 divided by -3, or -2/3. When the value for slope is negative, it means that your line is decreasing from left to right. Okay? Now, how would you get the equation of the line? Well, let's take an ordered pair xy on the curve that's any ordered pair xy. If we take any 2 points on the line, could be these two, could be these two, could be the 2 we've already used, the slope has to be consistent. So I'll use these 2, okay? And I'll say change in y divided by corresponding change in x, which is rise over run, has to produce a value of -2/3. That's simply the slope calculation. If I decide to multiply both sides by x minus 3, and we have y minus 0 equals -2/3 times x minus 3, this is the form of the equation of a line that we most notably call the point slope form. But please understand, the equation of the line is right here. I mean, it is the slope formula. Now, if I choose to clean this up by distributing, collecting like terms and all of that sort of thing, then we end up with a form that we often refer to as slope-intercept form. And what's notable about slope-intercept is that you can clearly see the slope, which was here and here, as the coefficient on x, okay? And you can also clearly see the y-intercept that we already knew we had, okay? So those are our options for writing the forms of the equation of a line. Now let's look at some different types of lines. You see in the figure before you I have drawn a horizontal line. If you have a horizontal line, this one passes through 0, 1, and 1, 1. The slope is 0, which means the change in y is 0, and the equation is simply y equals the y-coordinate of one of your ordered pairs, or you could say y equals the y-intercept. If you're a vertical line, your x-coordinates are the same, so your change in x is 0, and your slope by calculation, change in y over change in x, is undefined. Okay? So here we have a slope of 0, here we have a slope that's undefined. These two special cases of lines, however, the equations are most easily quantified by which part's the same. Here the y-coordinates are all the same, here the x-coordinates are all the same, so y equals the y-coordinate, that's the equation of a horizontal line, x equals the x-coordinate is the equation of a vertical line. You see here two parallel lines, and we can observe without proof, but we can prove this, that the slopes are equal. To perpendicular lines, the slopes are negative reciprocals. Now what would that mean? Okay, so let's just make an appearance here. The slope of this line is 1, and so is this one. The slope of this line is 1. The slope of this line is -1, but reciprocal means 1 over. Negative means opposite. And here's just another visual tool. 4 lines are given and labeled A, B, C, and D. Now we know that if the slope is positive, the line is increasing. If slope's negative, the line is decreasing. So I've assigned some values to these slopes and based upon the rise over run ratios. So if I'm going to have a slope of 2, for example, then my rise is going to be larger than my run. It may be something like 2 to 1. Okay, whereas if I'm having a slope of -1/2, my line is decreasing, but my rise is smaller than my run. Okay, so you can see these in order. If the slopes are positive, then the larger the number, the steeper the line, comparing these two. If the slopes are negative, it's backwards because the number -2 is smaller than the number -1/2. So when you go in order of their slopes, larger to smaller, or excuse me, let's do smaller to larger, that would make more sense. Then the line with the smallest slope is the one with the most negative slope, and that's line C. The next guy would be line B, and then staying in numerical order, positive slopes D, and then A.